Hello, welcome to my YouTube channel. Thank you, returning subscribers. My regular viewers, thank you. New viewers, you're welcome. I'm happy to have every one of you today. Today we are going to talk about the law of conservation of linear momentum. You know, we started this linear momentum yesterday with force, impulse, momentum, doing the calculations and all that. Please go back and check the video and watch it so that you can follow through today's lesson. So today we are going to talk about the conservation of linear momentum. Before we go into that, let me remind you of the Newton's laws of motion. Newton's first law of motion, Newton's second law of motion, and Newton's third law of motion. So Newton's first law of motion states that everybody will continue in their state of rest or uniform motion in a straight line except acted upon by a force. That's the first law of motion. Now remember the second law of motion, the one we did yesterday, that Newton's second law of motion states that the rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction of the force. Please take note, it takes place in the direction of the force. That statement is very important. Attach it to the second law, that the rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction of the force. Now, the third law states that action and reaction are equal and opposite. The combination of the Newton's second law and Newton's third law results in this conservation of linear momentum. Combination of the second and the third law. As a reminder again, the second law, Newton's second law of motion, states that the rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction of the force. Now, Newton's third law of motion, action and reaction are equal and opposite. So the combination of these two laws results in the law of conservation of linear momentum. The law of conservation of linear momentum states that in a closed system of colliding bodies, the linear momentum before collision is equal to the momentum after collision, provided no external force acts on it. Please take note again, very, very important. The law of conservation of linear momentum states that in a closed system of colliding bodies, the momentum before collision is equal to the momentum after collision, provided no external force acts on the system. For colliding bodies in a closed system, let's consider two cases. Case 1. Let's consider two bodies A and B of masses m1 and m2 moving in the same direction. Remember, they are moving in the same direction with velocities u1 and u2 respectively. After collision, their velocities were v1 and v2. Okay, you can see momentum before collision, that's m1 u1 plus m2 u2. And momentum before collision, that's momentum after collision, m1 v1 and m2 v2. U is velocities for the initial, yv is the velocity after collision. So before collision, we have m1 u1 plus m1 u2. And after collision, we'll have m1 v1 plus m2 v2. Applying the principle of conservation of linear momentum, remember that the momentum before collision is equal to the momentum after collision. So see the equation for it. In case 2, let's consider two bodies A and B of masses m1 and m2 moving towards each other. They are moving towards each other. Remember that in case 1, they were moving away from each other, while in case 2, they are moving towards each other with velocities u1 and u2 respectively. After collision, if they have common velocities v, we are going to see the momentum before collision. You can see momentum before collision m1u1 plus m1u2. And then after collision, if they are going to move with common velocity v, capital letter V this time around, so momentum after collision is going to be m1 plus m2. That's adding the two masses together and then the common velocity v, because they are going to move with common velocity. So applying the principle of conservation of linear momentum, we are going to have the equation shown below. Please encourage me by dropping your comments, like the video, just give that video a thumbs up so that YouTube will keep sharing it to others. Just encourage me. The more you encourage me, I'll keep giving out more content, teaching, doing calculations, spending a lot of time bringing out questions to help you. Please like the video, drop your comments and subscribe. If you have not subscribed, please do that now. Okay, before we go into calculation examples, I want to talk about the two types of collision. We have two types of collision: elastic collision and inelastic collision. Very important. Please take note of it. It can come out in the theory question. In an elastic collision, momentum is conserved and kinetic energy is conserved. Remember, momentum is the product of mass and velocity mv, and kinetic energy half mv squared. Both of them are conserved in an elastic collision. In an inelastic collision, momentum is conserved, but kinetic energy is not conserved. There is energy loss in an inelastic collision, and this energy loss can occur in form of energy loss due to energy can be lost to heat energy, sound energy, or elastic potential energy. So in an inelastic collision, momentum is conserved, but kinetic energy is not conserved. Please, this is very important. Just pay attention, focus, concentrate, don't get distracted. Watch this video to the end. You're going to learn a lot. Before we go into calculation, I want to tell you that there are 3 things you are expected to know. In the calculation aspect, they can ask you to find the momentum before collision or after collision. They can ask you to find the velocities with which the body moves, either before collision or after collision. And also, they can ask you to find the kinetic energy before or after collision. So let's go straight into the calculation right now. Please focus and watch this video to the end. Let's go to the first example. An object of mass 5 kg moving with a velocity of 12 meters per second due north hits a stationary body of mass 7 kg. If they stick together after collision and move with velocity v due north, calculate the magnitude of v. Okay, the first step is to write out all the parameters that we are given. We have the first one, M. M for the first body is given as 5 kg. Moving with velocity, initial velocity for the first body, U1 is given as 12 meters per second. And then this body is moving due north. It hits a stationary body. It means that the second body of mass, 7 kg, M2 is 7 kg, is stationary. So U2 is 0 because it's stationary. The first body was moving and the second body was stationary. So after collision, if they move with common velocity v, let's use capital letter to represent the velocity after collision, then we are expected to find the magnitude of v. So we are going to find the momentum before collision and find the momentum after collision. Momentum before collision is equal to momentum after collision. Then we'll get what we are looking for. This is the momentum before collision. M1U1 plus M2U2. And that is equal to M1, we have it as 5. U1 is 12. This is momentum before collision. Then for the second body, M2 is 7. But 7 times 0 because the body was stationary to make everything to be 0. So what we have here is 5 times 12. 5 times 12 is 60. So 60, this is the momentum before collision. Let's get the momentum after collision. After collision, we are going to have that M1 plus M2, they are moving with common velocity v, is equal to 5 plus 7 over v. 5 plus 7 is 12v. So this is the momentum after collision. This is the formula we are going to use to solve the problem. Momentum before collision is equal to momentum after collision. Please, if you didn't watch the video on force, momentum, and impulse, go back and watch the video so that you can follow through. Remember that momentum is the product of mass and velocity. So we got the momentum for the first body, that's M1 and U1, mass and velocity for the first body. For the second one, M2, U2, mass and velocity for the second body. That is momentum before collision. Now, after collision, the two bodies move with common velocity v, M1 plus M2, then factored out, or U because over factored out, and then v because they move with common velocity. Note that in this calculation, the direction is very important. We'll get an example that have different directions. If they are moving in opposite direction, there will be the U1 and U2 will have opposite signs showing that they are moving in opposite direction. But this one, they are moving in same direction. So momentum before collision, 60 is equal to momentum after collision, 12v. Okay, so 12v is equal to 60v. We divide both sides by 12. 12 will cancel 12. So that we'll have V to be 60/12. 60/12 will give us 5 meter per second. The second example, a ball P of mass 0.25 kg loses 1/3 of its velocity when it makes a head-on collision with an identical ball Q at rest. After the collision, Q moves off with a speed of 2 meters per second in the original direction of P. Calculate the initial velocity of P. So this question is similar to what we just did because they move in the same direction after collision. But the only different thing here is the velocity. Let's write out everything we have to be careful with the velocity because the value of the velocity was not given. Rather, they gave us that velocity for the first one is 1/3 of the second one. So we have to find the values for this velocity. Let's start with writing out everything. The first body M1, the mass is given as 0.25. Then the body U1 moves with a velocity. Let's call the velocity V. Let's call it V. Let's just use small letter V for it. Then it hits another body M2 at rest. So it means that M2, the mass will be there as 0.25. Okay, they are the same mass. But in this case, U1, U2 for this body is 0 because the body was at rest. Now, remember that after collision, this body loses 1/3 of its velocity. So if U1 is equal to V, let's get the velocity V1 after collision. So the velocity for the first body, we have to be very careful. Remember that this first body, okay, let the initial velocity for the first body, U1, let's just call it V. That's for the first body. And remember the question says loses 1/3 of its velocity. It means that after collision, the V1 will be the initial one, which is V minus 1/3V. Why is it 1/3V? It is 1/3V because the body loses 1/3 of its velocity after collision. Remember, V1 is for the first body. Okay, so we have to get the velocity V1 for the first body after collision. Don't mix it up with V2. V2 is for the second body Q and is given as 2 meters per second. But we are still looking for V1 first, which is for the first body. 1 is for the first body, 2 is for the second body. So let's get this V minus 1/3V. That will give us 2V/3. So this is our V1 now. So we have our U1, we have our V1. For the first body, the momentum before collision will be for the first body M1, U1
that's before collision, for the second body is going to be M2U2. Now, after collision for the first body, M1U1 plus for the second body, M2U2. Momentum before collision is equal to momentum after collision. So let's put in the values and get what we are looking for. But remember that this body, they all have the same mass, 0.25, 0.25, 0.25. So they are identical balls. To make the calculation easy, we can factor out m since they all have the same mass. So for the first equation, we'll factor out and have u1 plus u2. And for the second equation, we'll factor out m and have u1 plus u2. Why are we bringing out the m? Because they all have the same mass. They are identical balls of masses 0.25. If they are not the same, just put in the values and do your calculation. Please remember to like this video, comment and subscribe if you are getting values. Don't get distracted, focus and let's do everything together. Okay, because they have the same mass, I can say m u1 plus u2 is equal to m, since it's all the same thing, so that I don't have to start to make the calculation faster. So m is giving us, remember that m is 0.25. I can have 0.25. Then what's our u1? Our u1 is just v, plus remember that u2 is 0. So this is what we have, is equal to m 0.25 again, then v1 plus v2. Remember our v1, we got it as 2/3. You know how we got it as 2/3v, plus our v2 was giving us 2. So we are going to solve this out. 0.25 can cancel 0.25, so that we'll have 0.25 cancel 0.25, so that we'll have that v is equal to 2/3v plus 2. So we can take 2/3v to the other side, so that we'll have v minus 2/3v is equal to 2. V minus 2/3v will give us 1/3v is equal to 2. So v 1/3v is equal to 2. We can cross it out, cross multiply, so that v will just be equal to 6 meter per second. So watch this video, watch it, come back. If you have any question, drop it in the comment section. If there is anything you don't understand, drop it in the comment section. Watch it like 1 or 2 times, so that you'll be able to understand everything. Just calm down and watch it. This one is not teaching in the class where the teacher teaches once and is off the class. This time around, you have it with you. If there is anything you don't understand, come back to it and watch it again. Please remember to like, comment and subscribe to this channel. Thank you.